Good morning and good afternoon, class. Today I will be discussing about Module 2 entitled Electronic Diagrams. But before we start, let us know the objectives of this discussion. So at the end of this discussion, you should be able to identify the different electronic diagrams, determine the electronic diagram rules, draw basic electrical symbols, and appreciate the importance of grounding. So in this video class, I will be discussing until basic electrical symbols only. So what are electronic diagrams? These are drawings that illustrates physical electronic components in their respective positions within a system, but not necessarily in their actual physical location. So we can see that last week in module 1 we already discussed about electronic diagrams, or electronic symbols rather. Now you already know the symbols of some electronic components. Now these symbols represents the physical electronic components. Now in these electronic diagrams, we can see that they are positioned based on their actual physical location. And that's we are going to discuss today, how to interpret and read electronic diagrams. So electronic diagrams can be simple and basic, just like this one. The basic electronic diagram composed of a battery, which is our power supply. Then we have a switch, we have lamp, and the connecting wires. Or electronic diagrams can be also complex like this one. But don't get anxious or don't get nervous because of these too many electronic components in this circuit. Once you know how to read the electronic diagrams, it will be easier for you to understand these complex electronic diagrams. So let's first discuss the different electronic diagrams. So what do you have in mind? Okay, correct. First, we have the schematic diagram. It looks like this. Then we have the block diagram, which looks like this. And we have the pictorial diagram. Basically, it looks like this. Okay, are you familiar with them? Okay, let's discuss each of them. First, we discuss the block diagram. So when we say blocks, what can we see in the block diagram? Okay, they use blocks, rectangles or triangles to represent components, group of components, or units of equipment. They used to represent internal components of an integrated circuit, calculators, or microcomputers. And it indicates with blocks the path of signal through the circuit, but it does not give any information about wiring connection of the components. So as you can see in the example a while ago, this block diagram is just composed of shapes like rectangles and triangles, and they represent a group of components. So not only it can represent one component, but most especially it represents groups of components or units of equipment. So just like here it says that it represents internal components of integrated circuits. Yes. So for example, this is a block diagram of FM transmitter. So each rectangle represents a unit or a circuit in the FM transmitter. So we have the preamplifier, the AM modulator, power amplifier, and the antenna. So in any of these blocks, you cannot see the actual components. But this, for example, preamplifier is composed of many electronic components. Okay, So now you can see the difference. The pictorial diagram. Here is an example of a pictorial diagram. So what can you see? Can you see the difference between the block diagram and the pictorial diagram? Sometimes it is called wiring guide. Why? Because in here you can see the pictures of the actual component as if you are looking at the actual component, like the resistor, the antenna, the earphone socket, the tuning capacitors, and the mounting base included. Then it is called wiring guide because you can see how the components are wired. And like this one, the resistor is wired here in this terminal of the mounting base and on the other side of the earphone socket. Okay, this is very clear but very tedious diagram to make, obviously, especially if you don't know how to draw. Okay, so often photos with labels or highly detailed drawings of the physical components. It shows the wiring connections of components and also shows the auxiliary hardwares such as terminal strips, fuse, holders, switches, AC cord, and plug. So it also includes other auxiliary, those components that are not part of the circuit, just like the mounting base, the socket. Here, even included the water pipes. And when intended for assembly lines, it includes color coding of wires and some components like the resistor or the antenna. You can see there's color indicated like the blue and green, red, like that. So the third is the schematic diagram, which is the one we will be using here in our subject. So like this example, we have the dark activated switch circuit schematic diagram. What can you see? What components can you see? Of course, it shows the components and their interconnections. So we have studied the electronic component symbols like this one, and this one. And then it shows their interconnections. So how are they connected with each other? Each graphic symbol is also accompanied with a reference designation to distinguish it from other similar symbols. So as you can see, there are codes, values that are written in each component to differentiate each component with each other. It is a diagram that shows the functions and connections of a circuit by means of graphical symbols or abstract symbols. So we do not use the actual picture or drawing of the component, just like the pictorial diagram a while ago. But this one we use graphical symbols or abstract symbols. So what are the components of schematic diagrams? So we take, for example, this circuit again. So what can you see? Yes, we have the symbols. What else? Yeah, there are lines, of course. What else? What else can you see? Oh, you see letters. That's correct. And also numbers. So these are the four components of schematic diagrams. So what do these represent? First, the symbols. It represents the physical components. So, for example, this symbol is for what component? Correct. Resistor. Okay. And this one with color blue and red arrow, what is this? Yes, this is an LED. There are also lines in the schematic diagram. So what does it represent? It represents wires or electrical conductors. So any conductive material that allows the flow of current. So here, the lines are representing the wires. Okay, what else? The letters. So why do we need to have letters in the schematic diagrams? Because it represents the name of the component. So, for example, this R is referring to resistor. Okay, later we will be discussing this more. And we have the numbers. Where can you see the numbers? We have the numbers here beside the R, R1, R2. So what does it mean? We also have numbers here, 9 to 12, 50, 1K. Okay, so what does this mean? First, we discuss about the symbols. So symbols are graphical or abstract symbols which represent electronic components. So there are rules on symbols, on how they are placed in a schematic diagram. First, they can be placed horizontally or vertically. For example, this resistor, it can be placed like this one. This is vertical, and this one is horizontal. Okay. The meaning of a symbol does not change with its position or orientation in a diagram, its size, or line width. So, say for example, this resistor is written small while this capacitor is bigger. So, it doesn't mean that this, if we write the capacitor is smaller, the value or the symbol or the meaning of the symbol will change. Okay? Just like this one, if we use the IEC drawing for resistor, it doesn't change the meaning of the symbol. Okay. So examples of the symbols and their components that they are representing. So resistor, capacitor, we have the transistor, diode, chip or IC, and the switch. So there are lots of symbols available and being used in electronics. So it's up to you to research those and take note of them. Then the lines, they represent the wires or electrical conductors. We also have rules on lines. Okay. Lines should be placed horizontal or vertical. Or if necessary, for example, the space is not enough, you can draw the line in an angle but 45 degrees, just like this one. So this line is horizontal, this one is vertical, and this one is at angle of 45 degrees. So, by the way, these rules are agreed upon by associations of electronic engineers internationally. Okay, just like we mentioned, for example, the IEEE. They are the ones who make standards, and the engineers agreed upon these rules. Okay. 2 or more wires crossing each other without a node or black dot, meaning it's not connected. We already discussed this last time. So this one, even they cross each other, it means it is not connected. Even this one and this one, this is called line hop, HOP. Okay. You may be confused because in your module, this drawing in the middle says that these 2 lines are connected. So we have old reference or old convention, old rule for this, that this is connected. But maybe in the module they use the old convention, but now we are using the new convention or the updated convention, which says that this is not connected. So to avoid confusion, we will be considering that these lines are not connected. Okay, without black dot. When two or more wires crossing each other with a node or black dot, they are connected like this. So meaning we can say that lines are connected or interconnected, even how many lines they are, as long as they have a black dot, meaning they are connected. But if they don't have that black dot, or it is hollow like this one, it is not, or they are not connected with each other. We just simply think that they are insulated wires that cross each other. So therefore, no connection between them. Then the letters, it represents the name of the electronic component in a unique code. So prefix or parts designator code. So we call the letters prefix or the parts designator. That made up of letters and numbers depending on how many the same component available in a schematic. So for example, a resistor, its prefix is R. Okay. For capacitor, what? It's C, of course. For diodes, what do you think? Okay, if you said D, it's correct. For transistor, no, it's not letter T, it's letter Q. Okay. For inductor, it's L, not letter I. And switch, S or sometimes SW. IC, sometimes they use IC or letter U. So don't get confused. If you found it as letter U, then it means it's an IC, or otherwise they call it IC. For the transformer, then we use letter T. So that's why we don't use T for transistor, because it's for transformer. Okay, so there are other prefix that are being used, so it's up to you again to research this prefix and parts designators being used for electronic components. Then we have the numbers. Numbers represent the value of electronic components. So if the letters represent the name, the numbers represent the value. Example, for resistor, it shows how many ohms is required in the circuit. So like this one. So for this R, this resistor, it is 50 kilo ohms. So it shows the value of the resistor in ohms. So it is added to the prefix. This is another use of numbers. It's added to the prefix to make the component name unique if there are more than one of the same type. So example, there are two resistors in the circuit, like this one. So instead of using just R here and R for this one, so we need to make them unique since they have different values. So we attach a number to the prefix. So like this one, R1, and the other one is R2, R3, and so on. Okay. Same with Q1, Q2, Q3 for transistor. The value of components like IC and transistor is indicated by combination of letters and numbers. So you can see here in the transistor there are letters and numbers. BC547, it does not indicate the value. Instead, it indicates the name of the component or the code of the transistor. Same with the IC. Okay. Other rules and conventions. So signal flow of the current should be from left to right and top to bottom. Usually, yung circuit, when we draw it, or the diagram, the power supply is on the left side. So if you trace the signal flow, it is from left to right. But sometimes there are circuits that the power supply is on the right side. So we just check where is the positive or the negative of the power supply. Then we start tracing them. So later we will discuss how to trace the schematic diagram, or from top to bottom. So from positive, because positive is on the top and bottom is on the negative. Voltage potentials are indicated with the highest potential placed at the upper portion. So I think I mentioned this before. The lowest potential voltage is the negative terminal, or the zero as the reference point. So it has the lowest potential. So in the diagram, it should be on the bottom part of the diagram. We don't draw the ground on top of the diagram higher than the positive of the voltage. Power connections are commonly shown without any symbol, just a label showing the type of voltage. For example, we don't always see the symbol of the battery or the symbol of the AC source. Sometimes they just indicate V plus, meaning this is the positive side of the terminal of the voltage, or you can see V, 5V, 12V, or the value of the voltages, but you can see the symbol, so it's just okay. Then the standard symbol for a terminal could be added to any symbol but should not be considered as part of the symbol itself. So for example, a resistor, they put this symbol on both ends, this circle, small circle on both ends, that represents the terminal, but we cannot say that the symbol of the terminal is included in the symbol of the resistor. So you can opt to not to include the terminal symbol. Some rules and conventions. So some components on the circuit board are polarized, meaning one side is positive and the other side is negative. This means you have to attach it in a proper way. Okay, so you have to attach it a proper way. So there are components that have polarity. So can you name some components with polarity? Okay, let's take a look at the examples. So what is this? Correct, this is an LED. It has a polarity. As you can see in this physical component, there are some indications to identify which is the negative and the positive. So we have on its terminals, we have the longer one and the shorter one. So which one is the positive and which one is the negative? Do you know? Okay, let's take a look. Okay, so the longer side, or the longer terminal, or the longer lead is the positive, while the shorter is the negative. Okay, what if this LED is already used and the terminals or leads are already cut equally in length? So how do we know? So as we go on, you will be encountering other signs or indications to identify where is the negative or the positive side of the LED. Next, we have the battery, of course. We have a shorter line and longer line to indicate the positive and negative. So which side is the positive? Okay, correct, the longer side, and the shorter side is the negative one. How about this diode? Diode has an anode and a cathode. The anode is the positive side. So it's, here, the triangle. Then the cathode is the negative here in the wall. Just like the video before, it's like an arrow bumping in a wall. Okay, next we have the diode. Capacitor, sorry. So how do we know where's the positive and the negative side of the capacitor? So this symbol is polarized capacitor, meaning there is a positive and negative. So yes, the straight line is the positive and the curved line is negative of the capacitor. Very good. Okay, let's go back to the other rules and conventions. So there is also a rule for interrupted lines. So meaning, when a connecting line or group of lines could not be directly continued to its final destination. So maybe there is not enough space. So arrows or brackets with designation of the destination could be implemented. So like this one. So like this first picture. So instead that this line will be connected to the positive of the battery, it just indicated, it put an arrow, there is an arrow placed, then an indication to V positive, meaning this line will be connected to the positive terminal of the battery. Also this one. So instead of connecting this to the jacks, it just indicates that 2 input jacks. So meaning these 4 lines will be connected to the input jacks. Okay. Then we also have rules for dash lines. We use dash lines in schematic diagrams. So there are 3 reasons why we use dash lines. First, dash lines may be used to indicate an optionally connected component, like this one, this first picture. So here you can see this LED is connected using a dashed line. So meaning you can or you cannot, you may or may not add LED here. So the circuit will still work. So this LED is just an indication that there is a current flowing in the circuit. Okay, so without LED, you do not know if it is working, but it is. But you can know it more if you put LED. So it's up to the builder of the circuit if he will or will not put LED here. So it's optional. So we use dash lines. Another one, we use dash lines to indicate component content enclosed in a single unit. So for example, this transformer. So this is the symbol. It's composed of a capacitor and coil. And on the other side, it has also a capacitor and a coil. But these components are enclosed in one unit. So we put dash line to indicate that they are contained in one unit only. Okay. Then the other one, dash lines may be used to indicate mechanical linkage of 2 or more components. So like this, we are using dash lines to indicate that switch is linked to the potentiometer's swiper, the middle terminal of the potentiometer. So we use dash line to indicate their linkage. Okay. Okay, so I think you had enough, but let's remember there are steps in reading schematic diagram, considering these rules. So first, you recognize the component symbols. You should know first the symbols of the components. You cannot read schematic diagram if you don't know the component symbols. So you need to study, memorize, and understand the component symbols. Number 2, read names and values of components. So as mentioned, there are prefix and numbers together with the symbol in the schematic diagram. So you need to know how to read this. So if you see the prefix, you should know what type of component is that. Okay. Identify the polarity in terminals. We already discussed that one. and recognize the connections and lines. So you should be able to know if this is connected or not. Okay. So how do we trace schematic diagram? But first, why do we need to know how to read schematic diagrams? Okay, why are we studying these schematic diagrams? Why do we need to know? Okay, do you have any idea? Any idea will be accepted. Okay, let me start. Okay, for fault finding. So if finding faulty components. So for example, some of the, for example, your one of your device is not working or appliance is not working, and you have the schematic diagram, you can possibly pinpoint which may cause the problem. So then you will know how to troubleshoot. Okay, so if you identify, for example, this capacitor may be the cause because based on checking it's burned. So how to troubleshoot? We use the schematic diagram, check what is the value of the component so that we can buy and then replace, and how is it connected. Okay, and we can use also this schematic diagram for PCB designing. So if we want to design PCB like this one in a breadboard or a PCB, we need the schematic diagrams. Okay, you can also modify a circuit. For example, you want to improve it, or you want to add some noise cancellation, for example. So if you know how to read the schematic diagram, you know where to add that component. Of course, to improve safety, if you want to add safety device on that diagram or on that circuit or device, okay, you can use it. For example, you want to add fuse. So where do I put the fuse? Okay, you read the schematic diagram. So there are very many reasons that we can apply in our real life. Okay, so before we start tracing, here I have an example of a basic circuit. So as you can see, the black or hot wire is the positive and the neutral is the negative. So this is an open circuit because the switch is turned off and the bulb does not light up. Then this letter B is a closed circuit because the switch is turned on and current will flow from the positive to the negative of the supply voltage. But do you think really that the electron flows from positive to negative? Okay, this is a schematic diagram. The electrons are negatively charged bodies, right? So therefore, where do you think they will stay or will be located in the battery? Are they on the positive or the negative? Of course, they are on the negative. So electrons originate from the negative terminal of the battery. Then, since they are negative, they will look for the positive charge, and because they are attracted to the positive charge. So they will flow from the negative of the battery to the positive of the battery. So this flow is called electron flow because this is the actual flow of electrons. But in studying electronics, we don't use the electron flow. We use the conventional current flow, which is from positive to negative. This is also agreed upon by the engineers all over the world. That's why in all circuit diagrams, you see that the current flows from positive to negative because we are using the conventional current flow. Is the other way around. But we should always know that electron flows from negative to positive. Okay, is that clear? Yeah. Then conventional current flow. So when you're looking at an electric diagram, you are looking at a map of electrical current trying to find its path from positive to negative. Okay, that's what we need to know in order to trace the flow of current in a schematic diagram or in a circuit. So just remember conventional current flow from positive to negative. So once there is a power supply and the circuit is closed, the movement is always from positive to negative using the conventional current flow. Okay. So for example, we use again this schematic diagram for dark activated switch circuit. So what do? We start from the power source. So this one, we have a 9 to 12 volts battery. Then take note of the connections of the wires and components. So which wires are connected or not? So we have the node here, we have the node here and here. So meaning these two lines are connected, these are connected as well as these lines. Okay. Then trace all the paths of the current from positive to negative. So we must trace all the possible paths that the current will take in order to go to negative terminal. So we start from the source, okay, from positive, finding its way to negative. Okay, from here, then it will go where? It has two paths to go, down and derecho. Okay. Down, then if it goes down, then it will find its way to the negative. Okay, how about if it goes direct? Okay, it only has one path when it goes here, then afterwards it will go to the transistor. Okay, by the way, there is a node here, so meaning the current from here will be separated. Okay, then they will combine here and they will exit on this line going to the negative. Okay, this is how we trace the circuit current. Okay, so for example, this one is positive going to negative. So this LED is correctly connected because this is the positive and this is the negative side. So it will be forward biased and it will light up. But if you put this LED on the other way around, this will not light up because this is negative connecting to the positive. It will be reverse bias and it will not allow the flow of current. Okay, I hope you learned something about schematic diagrams. Now you have your homework. So what you're going to do, we have here two circuits. So applying your learning about schematic diagrams and their components, you need to label all the components here using prefix numbers and letters and numbers. Okay, prefix, and first you need to copy this drawing on your paper, then label them based on the prefix that is assigned for each component. For example, this 1K, for example, resistor. So there are lots of resistors, 1, 2, 3, 4, 5, 6. So you should label them uniquely. So you have R1 like that. Okay, and all the other components. Okay. And then you need to trace the current. Trace the current. Use different colors of pencils or ball pens. So here we have the the power supply on the right side. So based on conventional current flow, we use the flow from positive to negative. So you trace all the path of the current. So here we have the ground. So as you can see, the ground is not connected on the negative, but it has a symbol of ground, which means this should be connected to negative. So it ends or terminates here. Okay, it is considered as negative already. Okay. Okay, so how do we do? You should choose only one. Only one circuit will be assigned for you. Okay, here's what you are going to do. Count the letters of your surname. Then if the letters of your surname is odd number, you make circuit 1. But if it is even number, you make circuit number 2. Okay? Do you have any questions? Okay. If none, that's all for today. I will be posting your homework in our Google Classroom. And you will do this for this weekend. Okay, thank you for watching, and I hope you learned something. God bless you.